Okay, this is a grade 9 EQAO question, and it's to build a linear equation. So we've been given this information here. It says Rachel is paid $50 a day plus 15 cents for every tree she plants. So she's obviously working as a tree planter somewhere. They want us to build a graph and an equation to represent this relationship. And they give us a little bit of info that E stands for earnings and N is the number of trees planted, and they gave us a little graph to work with. Okay, can I fit it all in one view? Yeah, I can. Great. So our N was on the x-axis, which means this is the independent variable, right? The number of trees. And that makes sense because the more trees she plants, the more money she'll get, where E is her earnings. Now, they didn't give us a scale here. So this is something we're going to have to figure out. Let's work with the graph to start. So if she plants absolutely no trees, how much money will she make?
$55.
Yeah, it's pretty good, eh? She can sit there and do nothing and make $55. So we know that's going to be our y-intercept, and this is our y-axis, right? We know that her earnings are going to what? Increase or decrease from there? Increase. Okay, so on this scale here, we have a choice. We know that we're going to start at the number 55, but we just don't know where to put 55. If we put it way up here, we know the scale is going to increase, so we're going to run out of graph, right? And because it's increasing, it may not be a bad idea to start down here at 55. The only problem is it only increases by 15 cents every one, right? So we don't really want to go by 55s because then it's going to kind of be an odd scale. We're going to have a whole bunch of numbers we're going to be estimating. We want something we can work with. So we can start with 55, okay? We'll start with 55 as our lowest value. But our scale from there, maybe we'll just go up by a certain amount every time. Okay, maybe something like 5. So we go 55, 60, 65, 70, 75, 80, 85, 90, blah, blah, blah. Okay? But the problem is the very bottom is 0. So how do we represent this jump, this gap? Do you remember?
By the line.
Yeah, we use a little broken line here to say that this initial jump is not the same as the rest of the scale. Okay? So this is great. We have a y-intercept. Each of these dashes, because they give us the number 10 here, or sorry, 100, is representing 10. So let's try to go up by 10 every single time. How much money does she get to plant 10 trees? So if n is equal to 10, how much money does she make? How can we figure that out? How much does she get for one tree?
Oh, 15 cents.
Yeah, so if n is 1, she gets 15 cents, or $0.15, right? So if we're going to change it to 10, it's almost like a ratio. Okay, so let's write it like a ratio. When n, so these are the number of trees, is 1, her dollars are 15 cents, or 0.15. So if the n is 10, what are her dollars going to be? Well, we can cross multiply to figure this out, right? X times 1 is x, and then we have to do 10 times 0.15. Do you know how to do that? You can use a calculator. There's a fast way to do it.
150.
Yeah, 1.5, in fact. Okay, we just moved the decimal 1 over. Yeah, so it goes up $1.50 for every 10, which is great. This is going to be an important scale for us because our x-axis is going up by that much. So we got to go up by $1.5. Okay, so what is 55 plus 1.5?
56.5.
Yeah, 56.5, which is probably, again, we were trying to get away from estimating, something like that. So that would be the coordinate of 10 and 56.5. Okay? What about if we were at 20?
Then it would be 50. 50. So it's plus 1.5 each time, right?
Yeah, so $56.56 plus 1.5.
Oh, 58.
Yeah, great. $58. Again, we do a little estimating here. Okay? But we're eventually going to find a scale that's going to give us a pretty good number here. And 59.50. How about we look at the 100? Okay? How much would we increase by to go up by 100? And that number is going to be really helpful for us. Let's use that ratio scale we used before. N was equal to 1.15. If n is 100, our x's are unknown, so x is equal to 0.15 times 100. What number would that be?
$15.
$15. So we have to go up $15 from where we started. Where did we start?
At 55.
So what would be $15 from there?
80.
80. So at 100, we're at the value of 80. And really, to draw a linear line, we only need 2 points.
No. 70.
Oh, you're right. It is 70. Good. And maybe you saw that. If we tried to draw a linear line from our old ones, that really wouldn't have hit, right? And this is where it should be. That was way too steep. Good. So we figured out that mistake. So let's get rid of that. Put this coordinate in. You're right. 100 should be 70. So we should have $170. So when she plants 100 trees in a day, she gets up to $70. Okay, so we only really need 2 coordinates, those two. And it looks like this one we were off just a little. We can move it down. There you go. Okay, and that would essentially represent our graph. And we could find points in between if we really want to be extremely accurate. Maybe we find out at 50 what it is, and 50 would be like $7. But this is it. This is our graph. Okay, and really, again, we only need 2 points to represent the graph. So we've done that part. We've worked with a whole bunch of ratios to help us. The second thing we need to do is build an equation. Now, all linear equations are written as y equals mx plus b. And m is the slope, okay? B is the y-intercept. Do we know what the y-intercept is?
Yeah, 55.
That's right. So we know b was equal to 55. So right off the bat, we have y equals, m is still our unknown, x plus 55. We'll do that in blue. Do we know what the slope is, our m? Do you know what slope also represents?
No.
I'll put it here, slope. It also represents something called rate of change.
Oh, yeah. Okay, yeah, that one.
Does that make sense?
Yeah.
What is our rate of change here? For every 1 tree we plant, so every time we go over 1 on the x-axis, how much do we go up on the y-axis?
0.15.
That's right. It's also known as the change in y over the change in x. Okay? So for every 1, we go up 1.5. That's the rate of change. And the rate of change is how much money she's making. So what was the slope? You just said it out loud.
Oh, 0.15.
Yeah, it is 0.15. So y is equal to 0.15. And you had to have a bit of math knowledge to figure that out. So I'm going to add something to this. Okay, that's your equation. That's the correct equation. Let's say I couldn't quite figure out my slope, but I knew that y-intercept. So we had y was equal to, our m was still unknown, okay, x plus 55. There's another way we could have gone about solving for m. We just need a coordinate on our graph. And we have a coordinate on our graph. Remember, we had 170. That was one of our coordinates. We'll use this as an x value and this is a y value and isolate for m. So our coordinate we said again, so our red and green, was at 100 trees, she made $70, right? That was the number of trees. This is our dollars, so this is our x and our y. So we'll replace y with the number 70 is equal to m. Our x was the number 100 plus 55, okay? So let's say we weren't able to figure out that was rate of change, okay? We now isolate for m. So I move 55 to the other side, so 70 minus 55 is equal to, well, 100m, or 100 times n, you can write as 100m, okay? The difference here is 15 is equal to 100m. The goal is to isolate for m. So because this is multiplication, when we move it to the other side, it becomes division, okay? And 15 divided by 100 is 0.15 is equal to m, which is exactly what you said above. So we could have also isolated to find that question.